All right, so what we're going to do now is graph some transformations on trig functions, but I do want to get away from using those languages of transformations. And instead what we're going to do is look at what these transformations are going to do to our key features. The first one we're going to start with is this y equals 2 cos x plus 1. And so if you remember transformations, that 2 is going to start us with a vertical stretch of 2. And then the plus 1 is going to then follow that up with a shift upwards by 1. So this is really going to only affect the vertical aspects of our graph. And so what we can actually do, instead of starting with the graph and then doing all these kind of annoying transformations, what I'm going to get you to do is look at the graph from a kind of a box perspective. So if we start off with a cosine graph, I'd start with my 5 points. So I go top, middle, down, middle, top, and I'll connect the dots, make it smooth. But what you're going to get if you look at this, so I'm going to actually label that as, this one I'll do in degrees, I'll do the next one in maybe radians. So if we label that, that's going to be 1, and then this is going to be -1. What we can do is actually sort of just put this answer into a little bit of a box. And yeah, so we get this rectangle that we can sort of fit this whole shape in. And so the top and the bottom of the rectangle, this is my maximum at y equals 1, and my min at y equals -1. We also have a center, which I usually like to label as well. So the center typically it starts at 0 for your sine and your cosine curve. And then what we have on the outsides are the two, I want to use colors that I'm not using over there. So for the outsides, we have the starting point at 0. And then what we have is the period of 360 degrees. And so that tells us where it ends as well. 360 degrees over from the starting point. So what we want to do is draw that box, and we want to see what the graph is going to do to that box. So the vertical stretch by 1, instead of thinking of it as that, what it's going to do is it's going to stretch the box. So it vertically stretches that box by 2. And so what that's going to do is going to move the min and the max. So the max is going to become 2, and the min is going to become -2. But an even nicer way of thinking of this is what we're going to call is the amplitude. So this is something we're going to take from this. So the amplitude is going to come from this key number. Amplitude. So it's going to be a equals 2. And so what that number is going to tell us is how far up and down we go from the center. And then that shift upwards by 1, technically we're actually going to do that first, but that's okay. So that shift upwards by 1, what that's going to do is shift the box up by 1. And what that's going to do for us is it's going to move the center up to y equals 1. And so what I'm going to do with that is basically draw a function that has the same other features. We haven't affected any of the horizontal features, but we have affected the vertical features. So what I'm going to grab from this info here is that the center axis is going to be at y equals 1, and the amplitude is coming from the number out front is a equals 2, so that tells us go up and down 2 from the middle. And then my starting point and my period are unaffected. There's nothing going on inside the function. So those should both be in degrees. That right there is exactly the information that I need to draw that box. And so I should be able to put that together. All right, so I will draw my axis. So that's going to be 360 degrees, and I'll draw a few more in each direction. And then I need my Y scale here, so I'm not going to label these because it's just going to be 1, 2, 3, 4, 5. All right, so what I'm actually going to do now is get rid of the numbers that I've written over there because that's my transformation order. I'm going to probably actually look at these a little bit differently. I'm going to start with my center axis at y equals 1. So I'm just going to draw a nice dotted line for y equals 1 to tell me where my graph is centered. And my amplitude is a equals 2. So I'm going to draw that next. And what that tells me is I just go up 2 and down 2. So the amplitude is just telling you how far you're straying from the center. And nothing's affected the horizontal, so it will start and end at 0 and 360. And yeah, I'm gonna now draw those 5 points in that box. And so my general shape for the cosine is this like dippy 5 points. So I'm gonna draw them. And then just try to smoothly connect the dots. And then we're going to keep following that pattern to the left. It should actually go on forever. And that would be the graph of our function right here. So the 2 cos x plus 1. So I think before we move on to one that actually gets some horizontal stuff going on, I'm just going to basically just try to generalize this. So if we have y equals, so it'll be the same letters that we're used to, a cos of b x minus h plus k. We're going to view these letters instead of transformations just as what they're going to do to that box. So my vertical ones, my k is going to give me my center axis. It's going to be at y equals k. My amplitude is a. And that h, that's going to shift everything to the right by h. So what that is going to do is tell you your starting point. We normally start at 0. It's going to shift actually to h. And then the period is actually going to come from b. So remember that multiplication of b, that actually gives you a horizontal compression. So if you have a period of 360, it's actually going to be compressed by b down to, it's going to get squeezed together like an accordion. It'll either be 360 over b or 2 pi over b, depending on which units you're using in the question. So that's actually all the information that we need to put that box together. And it's going to be a lot easier to draw these as just a box, fill in the holes, than it's going to be to try to draw these curves like 4 or 5 times on the same axis. All right, so this one's going to be a little bit harder. We've obviously got a lot more going on. I'm also using radians. Just means you have to be a little bit mindful of how you make your scale, but don't stress out too much about it. Yeah, so we're going to have y equals 3 sine of a half times x minus pi over 2 minus 2. What we're going to do is just go grab those letters and use it to put that box together. So my first one, I'm going to do that minus 2 is my k. So my center axis is going to be at y equals -2. And then my amplitude is the multiplier, the a out front. So my amplitude is a equals 3. And then I can grab the other information as I go. My starting point is going to be at x equals pi over 2. And then we have to be a little bit careful. Since I'm using the pi over 2, that does tell me that my units are radians. So I'm going to keep everything in radians there. And then my period is going to come from the half. So period is going to be, I'll use the 2 pi version because it's radians. So 2 pi divided by half should be 4 pi. And yeah, so I'm gonna have to make my scale. The x scale can be a little bit tricky because we have to make sure it's something where we can see pi over 2 and then this period of 4 pi in there. So I've given myself a good chunk of space here. My center axis is on the bottom, so I'll make it a little bit roomier on the bottom. And yeah, so I'll just go through and label these. Let's say if this is pi over 2. I'm not going to label all of them. I just want to know what I'm doing here. So that'll be pi, and then 2 pi, 3 pi, that will be 4 pi. So maybe I'll label every 2 pi here and just do a couple more. And that should be 6 pi. And then maybe draw 1 or 2 on the left. And then my y-axis, so it's centered at -2. Really can make this scale whatever I want. So that's -2, -3, -4, -5, and I need to go up a little bit as well. Okay, so what I'm going to do now is start with the center axis. This is definitely the order I'd recommend doing this in. So that's at y equals -2. Yeah, I think I will dot that line. It's not technically part of the graph. So there's my y equals -2, and then my amplitude is 3, so it tells me to go up 3 and down 3. And again, just draw a dotted line, which they don't give me that option. So up 3 and down 3 from there. I am certainly blocking some of my numbers, but hopefully you can still see them enough. I'm trying to get this dotted line maybe a little too fast and it's getting pretty ugly. Okay, so that's going to be, that should trap the heights of this curve. It's going to go up to a maximum height of 1 and down to a minimum height of -3. So it's going to be trapped and just keep bouncing up and down between there. Now we'll deal with those shifts. So we're going to go starting point of pi/2, which I have labeled. So that's going to be the starting point. And then now be a little bit careful on that period. The period doesn't mean that it ends at 4 pi. What it actually means is that the length should be 4 pi. So the entire length, if we're already starting at pi/2, which is one of those tick marks, we do have to go over another whole tick mark to make sure that that total length is a period of 4 pi. So notice that I am ending, so I'm going from pi/2 to what is actually 9 pi/2. So it has to go over by another pi/2. That should be my complete period. And so that is going to give me my basically my trap, my box to use as guidelines for everything. And then the only other thing I'm going to do here is mark down that I am using the, what color should I use here? Maybe purple. So because I'm using sine, that's going to tell me something about my shape. And that tells me the sine shape goes like up and then down like this. And that should tell me where to put all of those points. So I know I start in the middle and end in the middle. And in the middle, it's in the middle. So you can eyeball that or use your notifications. And then we go up and down. And then I'm just going to connect the dots. And that's a pretty good picture of my curve. And that should tell me to keep going. And then, yeah, it should just keep doing something like this forever. And that would be my, my function. So this is how we draw it. I want to draw one more with some negatives in it, and that should be it. Okay, this will be the last one. So again, I'm just going to follow all those numbers there. So one thing you'll notice is the minus out front, which will make it a little bit different. But we'll still just start with our center axis is going to be at y=3. So I'm going to try to draw this as straight as I can. Slightly smaller scale there. Our amplitude, so technically it might come from that minus, but that minus doesn't really do anything here. We kind of want the absolute value of that. So a -1 isn't really going to do too much because like I could say that's down -1 or up -1. That would just sort of change the direction of those two arrows. So what we would do is probably just take the absolute value of that thing out front and use that to get the guidelines here for my heights. I'm going to try to do these semi-straight. But what that does mean is that I haven't done anything with that negative symbol yet. So far, that's the same thing as a +1, which isn't good. So we do need to deal with that. I don't have a phase shift or a different starting point, so I don't have to worry about that. So there's none, so it's going to just start at x = 0. My period does change. I guess I'm free to use degrees since I didn't label this as radians. And so my period would be 360 degrees over 6, so 60 degrees. Doesn't really matter what you want to use for the scale here. I don't recommend anything like 10. Try to use numbers that are relevant for the angles that we're familiar with. So like, yeah, the 30s, 45s, 60s, those are good ones. So I'm going to make my scale 30. Actually, I might make it 15. I don't want to just jump straight into 60 because then my whole period is in this tiny little box. So let's do 15s. And that should work. And then I can get my period will be from here to here. And so where the minus is going to come in now is it's going to come in for the shape for me. So the shape is going to come from the fact that it's a negative cosine. So a positive cosine would be this big dip. A negative cosine is just going to flip that upside down. And it's going to be like a little mountain instead. And so I'm going to start actually at the bottom and then go up and then down. And that should be enough to get an idea of what this graph is going to look like. And then if you want, you could actually use a bit of precision to keep graphing these because we know it's pretty tight together. You can see a whole bunch of periods coming in here. And this would be a pretty good picture of this graph for you. Yeah, so that negative, you can just incorporate it when you do your 5 points in that box. It'll just flip them upside down. And that's the easiest way to take that into account.